at this question together on power. The question reads, the average power required to lift a 60 kg load to a height of 25 meters in 2 minutes is, take gravity equals to 10 meters per second squared. So this is the question we're given. Now how do we solve it? Solution. Now first thing first, we'll be deriving all that was given in this question. They said the average power required to lift a 60 kg load. 60 kilogram, that is for mass, is it not? So come here and write M is equals to 60 kg. Now what else did they say in the question? So a height of 25 meters. So we're giving height H as what? 25 meters. Now what else did they give? In 2 minutes. 2 minutes is for time. So we're giving time to be what? 2 minutes. 2 minutes. Now they also said take gravity G to be equals to what? 10 meters per second squared. And the question says the average power is, so big P for power is unknown in this question. So these are basically all we're given, and this is what we are asked to look for. Okay? Now observe something. This is the scenario being demonstrated in the question. A body was lifted from the ground level, okay, to a height. Now this is the height. They say the height is 25 meters. 25 meters. So the body was at this point. And the body has a what? Mass of 60 kg. So assume this is the body. And it's at this height. Now when a body is static at a height, okay, not moving, what form of energy does that body have? The answer is what? Potential energy. So keep that at the back of your mind as we progress. Now the question will ask us to find power. And we know the usual formula for power is power equals work done over time. That is if you were given the work done. Or you say power equals what? Energy expended over time. If you were given the energy. And in this case, we're neither given the work done directly, neither were we giving energy directly. But we know that at this height, the body possesses one form of energy. And what is that energy? Potential energy. And if that is true, it therefore means we can find the energy and then calculate our power. So we can now say energy. What form of energy does the body have at this very height? The energy is what? Potential energy. And we know the formula for potential energy, let me add P here, is equal to what? Mass times gravity times height. Do we have mass? Yes. Do we have gravity? Yes. Do we have height? Yes. So we can calculate our potential energy. So we say PE is equals to, in place of M, we say what? 60 times, in place of G, we say what? 10 times, in place of H, we say what? 25. 25. And this is basically what we now have from this very question. So we can now say, if we times everything, we have 1 0 0 1 0. Okay? This time this is 150, then we 2 0. And this will be the potential energy in joule. So our potential energy is 15,000 joule. But they did not ask us to calculate the energy in this question. We were rather asked to find the power, the average power. So once we know our energy, we will now fall back to this formula and say power is equals to energy over time. I hope we are still together. I hope we are still together. Now if you observe something, we were giving our time in minutes. Okay? So we now say from here, mind you, we're giving it in minutes. We don't work with minutes in physics. We rather convert to second. Watch how I'm going to do that. What is our power? Our potential energy. Our potential energy is 15,000 over, what is our time? Our time was given to be 2 minutes. But since we don't work in minutes, we will convert 2 minutes to second. How do we do that? From minutes to second, you multiply by 60. So whatever is the value, you will say times 60. Okay? Now, it will not be in second. So from here, let's see what will happen. This will cancel this, okay? This in this will give you 25, okay? So you now have 250 over 2. Mind you, we are still finding our power. So from here, what will be power? 250 divided by 2 will give you 125. 125. And that is the answer to the question. But do we stop here? No. We have to reintroduce a unit. And the unit for power to introduce is watt. Watts. Okay? And the symbol for it is capital W. So 125 watts is the average power for this very question.